we are moving on to chapter 5. I'm going to go ahead and calibrate this here quick. Chapter 5, we're going to be talking all about ratios, rates, and proportions. Okay, so we gotta figure out what each of these things are. So a ratio, what it does is it compares one value to another using division. Come on. All right, using division. That's close enough. So there's a couple ways that we write this. A lot of times we look at it like a fraction. So like for example, I could have 1/2, 1/2. That would be a ratio. I could also write it as 1/2. That's a ratio. Another way that I can write it is 1:2. That's another way that I can write ratios, right? So that's a ratio. A rate then is a specific kind of ratio that uses units. So that's what I'm going to say. It's a ratio that uses units. So some common rates that we talk about on a daily basis, right? You recognize this. Miles per hour, right? That is a rate. We could also have like, I don't know, pages per minute, right? So I could count how long it takes me to read each page on average. So I could have a rate of pages per minute. I could have a rate of I don't know, like we could do like cups per batch. Like if I was baking cookies or something, I could have a rate of cups per batch. So a rate is just a specific ratio that uses units. So then the last one here is our unit rate. So our unit rate is a rate, obviously. With a denominator of 1. With, oh goodness, this is not, let's try doing this one more time. Okay, see if that helps. A rate with a denominator, not really. Denominator of 1. So actually all of the examples that I gave for our rate examples would be an example of a unit rate, like miles per 1 hour, right? Talk about pages per 1 minute, cups for 1 batch. So that's what we're talking about when we're talking about a unit rate. We're talking about how much of the first thing do I need for one of the second thing. Okay, so then as we're talking about rates and ratios, we're going to look at each example here and match it with what the verbal rate would be, and then we're going to come up with a reasonable or realistic number that would go with that. So the first one, the rate at which you ran a 100-meter dash. Well, if I'm running a 100-meter dash, I'm going to need meters. So down here I see meters per second. this one's going to go with my meters per second. So the rate that it goes with then is this guy down here, meters per second. So when we're thinking about a reasonable rate to be doing this, let's take Usain Bolt for an example, right? Usain Bolt is the fastest man in the world. He recently broke a record when he ran the 100-meter dash in 9.8 seconds, which is ridiculously fast. So we figured out that that's right around 10 meters per second that he ran. And so when you think that the fastest man in the world can do it in 10 meters per second, we're probably going to be doing it a lot slower than that, right? So if we're thinking about how many meters per second we would run, we might do like, I don't know, if he does 10, maybe we do half. So we could run 5 meters per second. Okay. So that would go with this one. So the next one, the fertilization rate for an apple orchard. So if I'm talking about an apple orchard, I'm talking about a farm. So pounds per acre seems like a good fit for that one. Got pounds per acre over here. And I actually looked this one up because I wasn't sure what the best fertilization rate would be. And what I found was they told me that 50 pounds per acre was a good estimate. So maybe you know more about farming than I do, and that's completely wrong, but that's what I found. The next one, the average pay rate for a professional athlete. Well, that's going to be in dollars per year, right? Athletes make a whole lot of money. Earlier in class today, I said 6 million, and the class seemed to think that that wasn't enough. So let's go with 60 million. Okay, he would have $60 million per year. That one's going to go down there. Okay, so my last one, the average rainfall rate in the forest. That's going to be inches per year up here. It's going to go up to this next one. And I looked that one up, and that one on average is about 150 inches every year, which is crazy. That's a lot of water. Okay, so that's rates. Let's go ahead and look at the next page. We're going to do some examples of these. So there's a couple ways that we deal with rates. One of the best ways to figure out equivalent ratios is to use a ratio table. So we have a satellite in orbit, travels 18 miles every 4 seconds. So first it's asking me what is the rate. So it's not asking me what's the unit rate yet, it's just asking me what is the rate, what am I given? Well, I'm given that I go, ooh, hello. I go, this is not going well. Okay, I go 18 miles in 4 seconds. Okay, so my rate is 18 miles to 4 seconds. That's the rate that I'm going at. So then what I can do is I can fill in my table then. So when I've gone 4 seconds, I've gone 18 miles. After I've gone 8 seconds, if I'm going consistently, how do I get from 4 to 8? Well, I multiply by 2, right? So then 18 times 2 is 36. Now I'm going to look at how do I get from 4 to 12. Well, I multiply by 3, right? 18 times 3 is 54. Okay, so on and so forth. So I'm just looking for the constant change, and I'm plugging it in. So 4 times 4 is 16. It's going to give me 72. 4 times 5 is 20. That's going to give me an output of 90. Okay, so I filled in my rate table. Now I'm wondering, well, how far does the satellite travel then in 1 second? So let's think about that, right? I said that when we're talking about a unit rate, I want a 1 in the denominator. So I know that I'm going 18 miles per 4 seconds, right? So I can write that as a fraction. I want the denominator, the bottom part, to equal 1. well, what do I need to do to 4 to make it a 1? Well, what I can do is I can divide it, right? 4 divided by 4 will give me 1. So I'm going to divide the bottom part by 4. But if I do something to the bottom, I also need to do it to the top so that it stays the same, right? So I also need to divide the top by 4. So then what that gives me is 18 divided by 4, which is going to give me 4.5 miles per second. Okay, my satellite is traveling 4.5 miles per second. So let's look at some ratios. We prefer to have ratios be written in simplest form. They're just easier to work with that way. So if I'm looking at 8 to 14, I'm looking at, well, what goes into both 8 and 14? I know that 2 goes into both 8 and 14, right? 2 goes into 8 4 times. 2 goes into 14 7 times. My simplified rate is 4 to 7. Okay, and I'm just modeling my solution like my original question was. So then my next one, 36 even to 12 odd. Well, I'm looking at that, and I know 2 goes into both of those for sure, right? So 2 goes into 36 18 times. So I would have 18 evens. 2 goes into 12 6 times. So I would have 18 even, 6 odd. So now I need to look at it, can I simplify that even more? Well, yeah, 6 actually goes into both of those. So I know that 6 goes into 18 3 times. So I have 3 evens. 6 goes into 6 1 time. So my solution then is my reduced form, my simplest form is 3 even to 1 odd. Something, okay, let's do the next one and then I'll talk about something. So we've got 48 chocolate to 42 vanilla. I'm going to do a similar thing, right? I can look at this and clearly see that 2 goes into both of these. So 48 divided by 2 is going to give me 24. So I'd have 24 chocolate. 2 goes into 42, 21 times vanilla. So now I'm looking at, okay, I've got 24 and 21. So something that goes into both of those. Well, I know that 3 goes into both of those. So 3 goes into 24 8 times. So I would have 8 chocolate, 2, and then 3 goes into 21 7 times. So then I would have to 7 vanilla. So here's what I want to say about this. This is as obviously as simplified as I can go. I may not have recognized right away, in fact I didn't when I was even doing this one, that 6 goes into both of those numbers. Okay, I might not look at it and be like, oh yeah, I know that 6 goes into both of those. The one before this, the 36 even and 12 odd, I probably, if I would have thought hard enough, could have realized that 12 goes into both of those, right? But I didn't at first realize that 6 went into both 48 and 42. And so I think it's best to just take it one step at a time. I did a step that I knew would work. I knew for sure that 2 was going to go into both of those. So I divided by 2 first. And then I evaluate where I'm at. Can I reduce it more? And then I realized, oh yeah, I can reduce it more. So just take it one step at a time. That'll help. Okay, lastly then we're going to look at the unit rate. So my unit rate tells me that I need to figure out per one thing what I have. So $2.50 for 5 ounces. I want to know how much is it going to cost for 1 ounce. So I'm going to take $2.50 per 5 ounces. Oops. Okay. Well, I'm hoping that maybe you realized before when we were talking about unit rate that I can just divide by the second number and that'll give me my unit rate. So I'm going to take $2.50 and divide it by 5. So when I do that, I'm going to get 50 cents per ounce. OZ is a abbreviation for ounce, if you didn't know that. Here's what I'm going to say about this too. So a rate we talked about is a specific kind of ratio because it uses units. So because we're using units, we need to be careful that we include our units, otherwise it's not really an accurate answer, right? If I had just put down 0.5 per ounce, that wouldn't have made sense in context of my problem. I need to write out that it's 50 cents for every ounce that I have. So 50 cents per ounce. Same thing here, right? I've got 15 degrees for 2 hours. I want to know what it is for 1 hour, so I'm just going to take 15 divided by 2. So I get 7.5 degrees per hour. Okay, and then the last one, right? I have 183 miles in 3 hours. So I'll take 183 and divide it by 3. It's going to give me 61 miles per hour. Okay, so that's all I'm doing. I'm finding my unit rate. How much do I have per one unit? So that is all for 5.1.